back. Now we're going to go over the design process that I took there and everything that's included with the design. We've got all these standard details. I won't open those up. I'll open one up. How about that? So these are from the the International Masonry Institute. These are just standard CMU details. One of the reasons I put everything in this package was because I'm designing this now and I may not build it for like 10 years. I'll probably forget all this stuff by then. That way, if I go back through and build it myself, I'll at least have all these set aside. But, other people may need them too. If you're already a Mason, you probably don't need those details. And if you hire somebody, they'll probably do it however they do it. And this is one of the companies I found that offer a lot of rainwater storage solutions is Rain Brothers, and this is the cistern I had selected. It's a concrete cistern, below grade, of course. And I included some data for the region I'm looking at. And you should be able to find all this data. There's a website from ASHRAE that will provide all this data for whatever region that you are looking at. So you probably want to look this up when you're doing your design. Let me open that back up again. Just so you know, for heating and cooling, you typically either use the 99 or 99.6 for heating, and the same for cooling. You use either 0.6 or the 1%. What that means is 99% of the time you will meet this condition, or 99.6% of the time, if you design your air conditioning, it will meet those conditions that percentage of the time. So there's that small amount of the time that it won't meet those, it won't be able to heat or cool to those conditions. So I included this. This is the overall energy consumption for the house according to eQuest. I'm not sure how accurate eQuest is, but it gives you something to go off of. And according to the calculations, the solar system, the photovoltaic system that we designed should be able to meet these requirements and provide 100% of the energy for the building. Of course, you won't really know until you install it and try it, but it should cover that. Got a comparison of an ERV versus an earth-air heat exchanger. So I was on the fence about whether to do an ERV or an earth-air heat exchanger. So an earth-air heat exchanger, for those who don't know, is they call them earth tubes, or that's all I've heard them called for those two things. But it's just a pipe that's ran under the ground, and you blow air through it. And since the ground stays at a relatively constant temperature, in the summertime it provides cooling, and in the wintertime it provides heating for that air. I had thought about using that for an air conditioning system, but decided to, since we're already installing the heat pump, to save costs, to just use it for the ventilation air, which is what an ERV would also do. So I compared the cost of the two, and in the end I decided that the earth air heat exchanger was less expensive. And also, you should never have to replace anything on an earth air heat exchanger. Maybe some of the above ground pipe might eventually get broken, but with the ERV, you'll probably have to replace those every 10 or 15 years or something. So I thought in the long run it would probably last longer, and it's lower upfront cost. So that was the decision, and all that's in that design report there. And then I included the I-joist guide for the roof joists. Of course, it depends on what manufacturer you go with. I thought that manufacturer had some good details, so I included that. I won't open it up. I'll let you take a look at that. And then when we were looking at the design, we were I looked at the different types of insulation and what this heat loss wall temp profile. It's to determine what I used it for, at least, was to determine where, if you're going to get condensation, where that condensation is going to occur, because you want to you want to make sure that your insulation doesn't get wet and that you control the location at which the condensation occurs, which happens to be inside the insulation for both of these. So the only way to prevent that would be to install a vapor barrier on the outside. But instead, what we've done is we've included ventilation for the insulation, and also this was used to calculate the R value, which is used for the energy model. So actually, I guess it was probably more important for that, but it gives you an idea of where you'll get condensation. So in the summertime is probably when you'll get condensation, and that will occur, of course, in the exterior insulation for both the wall and the roof. So the R value for the roof the wall we ended up with was 28.7. That's with 18 inches of straw. It would be different if you used fiberglass like R30 fiberglass. It would probably go up about 5 points. And then our R value for the roof ended up being R65 with an R49 fiberglass. You might be able to reduce that to R38, but it's best to keep your roof well insulated. So, and of course, condensation occurs within the insulation for both of these systems. So you want to make sure and ventilate that insulation to minimize your condensation in the insulation. Now we've got this is the spreadsheet from ASHRAE that if you're an ASHRAE member, I'm not sure what year this came out. It looks like an older one. I was given this file, so this was used to calculate the HVAC systems for the house. You could probably also use this for rough energy calculations as well, but I just used it to size the heating and cooling system for the house. So you just want to make sure that for each floor that you have this much heating or cooling, and we have probably double that. So the heating is the one that you have to be able to hit. So you want to make sure and have enough heating. We could probably reduce the size of our unit just a little bit, but we'd have to take a look at that. And then I put together a bid form. I use this to create my own internal estimate. So, and also if you take this out to bid with contractors, you want to have some sort of a bid form that you can give to them so that all the bids you receive are easily compared. So these are the phases. So I wasn't sure if I'd have enough to do all the phases. It looks like we'll probably be able to do afford to do phases 1 through 5 and then the rest later. So that was the reason. You could just do phase 1 and you'd still have a 1,000 square foot living space. So that was the thought, was to start with 1, and then if I had to do all the work myself later, I could. So the different phases are laid out here. Of course, you can adjust those as needed. And then, of course, there's the bid form portion that breaks it out into all the different phases. And there's also some deduct alternates to if you change the CME walls to stud walls or reduce the story. If you guys think of any cost-saving measures, let me know, and I can add them to this bid form. And then, of course, there's the criteria. You'll have to check your local building code for this, but it gives the criteria for the International Residential Code for all the different values for your structural and plumbing and everything, and mostly your building design. It's got the insulation values. You can see our wall insulation has to be a minimum R13, which we're exceeding, and then our roof insulation also has to be a minimum R38, which we're also exceeding, and then the windows, I think we're just meeting that requirement. It's hard to find good quality windows. And then I've got the domestic water sizing spreadsheet that we created. And this will just help you size your domestic water. Of course, if you hire a plumber, he may want to go through and do this himself. The values given here and here are somewhat conservative, and there's instructions if you'd like to go through and resize it with your own design. Of course, you can always go to the plumbing code and size it that way. One of the things that was kind of difficult to come up with was this earth-air heat exchanger calculator. So I'm not sure how accurate this one is, but it should get you what you need. You input the green cells, and then the output is in the blue cells. And of course, you'll have to run two different calcs, one for the wintertime condition and one for the summertime condition. What I ended up coming up with was that I need 4 pipes that are 467 feet in total length in order to get the this is in the heating condition. In order for the heating, actually the pipes I came up with were much smaller. The cooling condition, I think, is the one that was more important, because you're only going to be able to heat the air up to about the ground temperature. So with 100-foot, with 4 100-foot pipes, the exiting air temperature was pretty much what the same as the ground temperature was. So that's about as good as it gets. I think we could go quite a bit smaller and would still get the same output, but that was the size of our foundations, so that's what size our length our pipes are going to be. And then we had the electrical sizing. We went ahead and just put in all of our circuits and an approximate amperage for each circuit, and then the overcurrent protection, and that's how we generated our 2 panel schedules. Of course, you probably want to have your electrician double check all that. Same with the plumbing. Of course, the estimate, we'll save that for last, because that's probably what you all want to see. So, heating and cooling square foot approximations. I just did some rough approximations based on experience for what to expect for the heating and cooling, and they were relatively in line with what data we got from eQuest. I included the eQuest file as well, so if you want to go in and edit anything or produce some extra data, you can. And then I compared all the different R value insulations to see which is the most cost effective at insulating, and it turns out fiberglass in most situations is the most cost effective. And since it's nowadays is about 50% recycled, it's also fairly environmentally friendly. I did read mixed concerns about health effects, but in general, the general consensus was that there were no adverse health effects. So it looks like fiberglass is probably your most environmentally friendly and cost-effective solution. Of course, maybe not environmentally friendly, but cost-effective. But we decided to go ahead and go with straw. It looks like, according to this spreadsheet, we could go with fiberglass and get either a higher R value for the same dollar amount or a equivalent R value for a lower dollar amount. So there's possibly some cost savings there. And of course, if you're going to use a cistern, you want to calculate the amount of rainfall that you're going to get and make sure that you're going to have enough water for everybody, because you don't want to run out of water. So I came up with about a 5,000 gallon cistern. Of course, it'll depend on how many people are living there and what kind of usage you have, but that's about as big of a tank as I could find in concrete tank anyways, so it worked out pretty good. The roofing, I did an analysis of the different roof types, and I decided with metal for a multitude of different reasons. One was the cost, but also it's one of the better ones for rainwater collection systems. But really, you've got multiple options that are good options. So it looked to me like the metal roof was the best option. And then we got a sanitary drainage spreadsheet. You know, it just follows the code requirements. You want to check all the code requirements for that. The solar heat gain coefficient for windows. I included this. I don't know how helpful this would be. You just want to maximize your solar heat gain coefficient for your southern windows. And then we've got our solar panel angles. This was from a spreadsheet, which I'll go over in the references. Or I'm sorry, that was from a website that I'll go over in the references. And then, of course, we had to come up with how much solar power we're generating and compare it to our usage to see if we're actually net zero energy. And, of course, this is just an estimated energy use consumption from eQuest. But it looks like we're just barely under. So will it be net zero? Only time will tell. The numbers say yes, but in actuality, we'll have to check and see. So I'll be interested to see. And also I did a little passive house comparison to see if we pass all these categories, and we do pass every category in order to meet the passive house requirements. I've tried to include all my references in all these different spreadsheets I've come up with. And then you have the vent pipe sizing. This is for your sanitary sewer vent based on International Plumbing Code requirements. And also I came up with ventilation rates. So these ventilation rates were used to size the exhaust fans for both spaces. Really you could run those exhaust fans 24/7 if you wanted to have the best indoor air quality possible. So of course you would have a higher energy consumption, so you'll have to balance that with how much power you have available. And then we've got the other export from eQuest, which was the sizing of the HVAC equipment. And you can see it requires 6 tons of cooling, and we ended up with 8 tons. If you do a 2-ton unit for each apartment, it'll be a 4-ton unit. I'm sorry, 8 tons, 2 per unit. But actually what you really have to look at is the heating. The heating is what really drives, and in this climate in central US, the heating is what really drives your system size. Then technical specs from your I-beam manufacturer, a foundation drainage detail that looked good. There's a precast cistern. There's this rainwater harvesting tool that I found online. You can go online and it will tell you at this website how much rainwater you can expect every month. And I just compared this to the values that I calculated using the International Plumbing Code and data I found for the region. Actually, I believe ASHRAE also provides data in that climatic data. And so this coincides with the information on the rainwater, the rainfall and water storage spreadsheet. This is just kind of a good double check. There's a lot of good information available online these days. Roofing instructions, that's just from a manufacturer. You can find that based on which manufacturer you go with for your roofing, metal roofing panels. And then I compared the different sizes of the septic tanks, and really I couldn't find much difference between the small ones and the big ones. The smaller ones have a lower upfront cost, but the bigger ones have a lower long-term cost. It probably all equals out in the end. And then SMACNA has a nice little program on their website to size your downspouts and your gutters. And I use that to size the downspouts and the gutters. This is actually one from Gray Construction that they created to size their downspouts and gutters. But also there's one from SMACNA that you can do online. And I use that as a double check to make sure that I had sized them appropriately. We ended up with 5-inch gutters for this one, and then we got a bill of materials for the supports for the solar panels, which that is also included. So now, of course, what everybody's been wondering is, what does all this cost? Now, you would think that a net zero energy passive house would be a lot more expensive than a standard construction, but I'd love to get some feedback on the estimate from some contractors that have experience with this. But from what I've seen, the cost is approximately the same for this design as what would be for a standard construction. So how I came up with this estimate is I used all the takeoffs from Revit for all the materials, and ended up at $169,000. This is only for phases 1 through 5, so this is just for the first floor, not the second floor. But for the first floor, it ended up being $169,000 for the materials. Now, when you factor in the labor, in general, in residential construction, it's generally 70% materials and 30% labor. So if you figure in the materials at 70% and the labor's at 30%, came up with a total of $241,000 for a high estimate. See, your materials, the material cost I came up with was, you can find the references over here on the right. These are all the Home Depot, Amazon, Lowe's, Menards, all the different stores you can find those materials at. And if you put together a bulk order, you can get anywhere from 10 to 40% off. So depending on the reduction in material cost, your cost could go down quite a bit. So I put together high, medium, and low costs for the house, and the high cost is $241,000, and the low cost is $181,000. So for a 2,000 square foot house, assuming this medium-low cost is the cost that ends up being selected, which I think either the medium-low or medium-high is most likely the true cost, you end up with a cost per square foot of only $103 per square foot for a 2,000 square foot house with an unfinished attic, with a 2,000 square foot unfinished attic and a 400 square foot basement. So that is in line with the standard cost of construction. Now, of course, it's by region. That'll vary, based on the labor costs. But in general, that should be the cost. The material cost shouldn't change based on your region unless you're in a very remote location. So, as you can see, this includes the solar system. This includes the solar system, the photovoltaic system, the power system. It includes the rainwater cistern. It includes the septic system. So it can't go up too much more. So anybody that says that you can't build a net zero energy home for the same cost as a standard construction, I'd have to seriously doubt that. Of course, I'll get a few quotes to see what it would end up costing, but if you built it yourself with all your own labor, you might be able to build it for as low as $126,000. That's a 2,000 square foot house, which, of course, that's all your own labor. That's going to take a little while. That's going to be a lot of hard work, but it's quite possible. So any comments or suggestions, or if there's any contractors that see this video and would like to submit a quote, please do. I'm sure that people in your region, and I especially as well, would love to see what this could be built for. Anyways, it's been a long video, almost 2 hours for me, so probably started rambling in there. And anyways, I hope you find it helpful, and if you have any issues downloading all the files or anything, the Revit files in there, all these design spreadsheets are in there, the drawings are in there. It should be a complete package that you can put in there. So if there's anything that you can't find, or if you have any trouble downloading any files, leave a comment. And maybe once we reach that 100 download limit on Google Drive, I may have to find another way to post it. One more thing to go over is all the references. I included all the references in a spreadsheet. And a shout out to Office Libre here. I use Office Libre because it's a free open source Office suite. You can get Word, Calc. This is Calc. It's a spreadsheet. And multiple different softwares. Of course, I use this one most frequently, and it works really good, and it's open source, so it's free. So I would recommend you make a small donation, but you don't have to. So if you need free open source software, that's the way to go. I did go through, I've got hundreds of references, but I went through and just filtered out just the ones that I thought were the most important. So anything that I haven't covered here, you can always take a look at these references and double check. Leave your comments and feedback, and if you'd like to submit a quote, please do. And appreciate it for watching. Good luck with your house design.